Hello everyone. Today we will be dealing with the concept of strain. In the last class we have dealt with the stress that is getting applied on the body. The stress can change its size, shape, volume, etc. So now we will be discussing about strain. When stress is applied on a body, there is a change in the configuration. So strain basically is defined as change in configuration by original configuration. Change in configuration by original configuration. So what do you mean by configuration? Configuration here refers to the size, shape, length, volume, etc. So can you guess what is the unit of strain? If a change in length is there, here there is original length, so what will happen? There will be no unit for strain. You have to note the point that strain is having no unit, no dimension. So a question can be asked to you. Can you give an example of a physical quantity which is having no unit and no dimension? That is strain. Then the strain can be classified into three that I have already written here. Strain can be classified into longitudinal strain, volumetric strain and shear strain. So first of all, we are discussing what is meant by longitudinal strain. Longitudinal strain. So how will you define longitudinal strain? It's the ratio of change in length to the original length. So what is it? It's the ratio of change in length. So you have already defined it is change in configuration. Instead of that configuration, you have to write it is the ratio of change in length to the original length. So how will you write longitudinal strain? Longitudinal strain is written as change in length. We will call it as delta L and original length. I may draw it in the picture. So there was a wire like that. We tried to extend it. So this was the original length. So in the second case, it extended a little so that the change in length is delta L. So longitudinal strain is delta L by L. So what is the equation of longitudinal strain? Delta L by L. As you know, this is some meter, this is also meter. It is not having any unit. Please note it. Next, we will deal with volumetric strain. In the last class, we have noted, suppose there is a bubble or a water drop. We are applying the force very uniformly so that there is a change in volume. So there happens a change in volume V. The original volume was V. So how will you write volumetric strain? Volumetric strain can be defined as the ratio of change in volume divided by original volume. In this case, when there is a change in volume, if it is lessening, the volume, if it is getting lessened, we can write that it is minus, because the change in volume is negative. In some cases, we should write it as negative. If there is an increase in volume, what is it? It will be positive. So in the case of certain theories where the volume is increasing, there should be a negative sign. And the next type of stress that we are going to deal is the shear strain. It's not the stress, it is shear strain. So the next is shear strain. Shear strain. So what do you mean by shear? Last day we have discussed it. We are applying a force tangentially. When we apply a force tangentially on a surface, so what happens? This is a fixed body here. We are applying a force like this so that the body changes its position like this. It gets tilted through an angle theta. So let delta L be the change here, or delta X. We may note it as it is delta X. A change is happening here. Delta X. And the original here, the edge length was X. So we have noted that this particular surface gets displaced through an angle theta. Here the angle theta is called the angle of shear. What is it called? Angle of shear. Angle of shear. And this angle of shear, when we write tan theta in this, can you see a triangle over here? We can see a triangle over here. So angle of shear, when we take tan theta of that angle, we will get the opposite side by adjacent side. So that is delta X by X. So shear strain is actually delta X by X. Let us just think about whether two types of strain can be produced in a single entity. So there is an example for you. Listen, there is a spring loaded here. So when a load is applied here, it gets extended. Can you think about the type of strains that is produced in a loaded spring? So the type of strains produced is of overall there is an extension, and also when there is the coil like spring is there can be a shear also. So a spring with a load is an excellent example where there is both shear is happening as well as a longitudinal strain is happening.